Hey guys, welcome back to my channel. This is Justin here, and we are on Freecodecamp.org. We are under the coding interview prep under the algorithm section, and today we will be looking at the pairwise algorithm here. So if it's your first time here, I release these type of algorithm videos on almost a daily basis. I also release React tutorial videos, JavaScript tutorial videos, anything related to coding, you will find it here. So if you like this type of content, please click like and subscribe below. Anyways, on with this question. Let me read the directions first for us. Given an array R, find elements in pairs, find element pairs whose sum equal the second argument, arg, and return the sum of their indices. You may use multiple pairs that have the same numeric elements but with different indices. Each pair should be the lowest possible available indices. Once an element has been used, it cannot be reused to pair with another element. For instance, 1, 1, 2, and 3 creates a pair 2, 1 using the 1 index, using the 1 at index 0, this one, rather than the 1 at index 1, because that will give you lower indices as a sum. For example, this example here returns 6. The pairs that sum to 20 is this and that, and we can write out the arrays, blah, blah, blah. Below, we'll take the corresponding indices and add them. Okay, so guys, please, I know I didn't do this question reading justice, but please read this a couple times to make sure you understand. And if you do understand, but you have never tried this before, please pause the video now and try it on your own first. And then come back to this video and I'll show you how I will solve it. So if you're still watching now, I'm going to assume that you have at least attempted to try this on your own. Let me bring this over here, the starting code, and this is what I want to do. Let's list a couple criteria, yeah? So first, what do we need to do? We can't use indices more than once. So if we were to use this one somewhere, let's say there was 2 6s here, for example, like so. And the reason why I'm saying 6, because the sum has to equal 7, right? If I pair this 1 and with this, the first 6 right here, I cannot use this 1 again and pair it with another 6 because then I'm using that index more than once. So that's rule number 1. Number 2, if an index can add with more than 1, then use the smaller index, smaller I, I'll just say, just to not go to the new line. So again, that goes in lieu with what I was saying. If we have a choice between this 1, 6 and that and the last 1, 6, then we go with the before one because that will give us a smaller sum. And I guess it's a rule, but I'm not going to write it down. The sum of the values must equal the second argument here. So I think that's the only rules that I am going to write to just keep myself accountable to these rules as I write this code. Now, we have to have some way to keep track of which indices, which values of these have been used. So this is what I'm going to do. Before we even begin this algorithm, I'm going to create an object, a dictionary, if you will, which gives me the input of it will be the indices of the array itself. So like 0, 1, 2, 3, 4, 5, like so on. And let me erase this example that I wrote here. I think it was just that, right? Yeah. And I'm gonna give the value to them all initially false, saying that they haven't been used. And as I start using them, I will convert those values to true. So for example, this one, how many indexes does this one have? 0, 1, 2, 3, 4, 5. So what I'm gonna make is I'm gonna make an object that's kind of like this. 0 is false, 1 is false, blah, 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 all the way till what? 0, 1, 2, 3, 4, 5, all the way till 5 is also false. I wanna make an object like this that keeps track of which one has been used or not. So I will call this const used dict for use dictionary. And I'm gonna use the reduce function on our array. So hopefully you guys are familiar with what a reduce function does. It's a method of an array. And it gets a callback function as a first argument. And we always used accumulator in the beginning. And we need what? Do we need the value of the element itself? I'll just write it here. Oh, I also need the index. So that's our third parameter of our callback function. Now the second parameter of this reduce method is the initial value of our accumulator, which I will initialize it as an empty object like so. And what I'm gonna do is within this, I'm gonna just return an object right away. So I'm gonna use an inline return like so, put a parentheses around these curly braces to let JavaScript know that it's an object that we're returning. And what I'm gonna do is spread our accumulator that we have made thus far. I will be our key and our value will be false. So we don't need to use the element that we're looping over for this reduce method. So you could just write this as L, or the traditional way of doing things. If you're not using the element or any of our parameters, we just put underscore like so. Hopefully that makes sense. Let's just make sure that we're on the right track. Let me console log use dictionary to make sure we get what I was trying to get. And yes, we do. We get everything with false. So that is good so far. Now let's get on with the algorithm. What I'm gonna do is I'm gonna do a for loop within a for loop. The first loop, I'm gonna loop through each of these guys right here, except the last one. And within the inner loop of that, I'm gonna compare that value with each of the ones that's coming after it. So let me show you guys. So the outer loop, I'm gonna use the I variable. That I is 0, I has to be less than array.length -1. I don't want to go to the last one because our I will be the one that we compare with our second variable, which I'm gonna call J. But if I goes to the last one, he has nothing to compare with. And let me just write this code first. Like so. And within this for loop, I'm gonna have another loop for J. J will compare with I. So if I starts here, J will start comparing with the 4 and then the 2 and then 3 and so on. So J will always start at I plus 1. J will go all the way to the end of the array and J increments by 1. Now, J will never be before I. And the reason for this is that will give us duplicates then. We are starting with I, so we're comparing 1 and 4, then we're comparing 1 and 2, and then 1 and 3, 1 and 0, 1 and 5, and then we go let I equal 4. We don't need to compare 4 with 1 again. So there's no reason for why J should be lower than I, because we already did that comparison, right? So J, the next iteration will be 4 and 2, 4 and 3, 4 and 0, 4 and 5, and so on. It will keep on going like that. Hopefully that makes sense. So we have to do something here. Let's see what we have to do. I'm just going to extract our values just so that I'm not writing array at I like this all the time. So I'm going to say const I. This is optional, by the way. You don't have to do this, but I just prefer doing this. Just keep my code a little bit more organized. We'll say the I value is just array at I. And within here, I'm going to say const J value is array at J. Now, this is what we have to do. If I value plus J value is equal to our second argument, which we call arg, then what do we want to do? I got a couple things that I gotta do. I gotta first let the use dictionary know that these values have been used. So let's do that here. Used value, use dictionary, at the index I is now true. Also, use dictionary at index J is now true because we have used these. Not only that, I need a counter. Remember, my output is going to be the sum of all the pair of indices, right? So let's set my output as 0. And whenever we had this happen, we're going to add to our output. So output is going to equal, we're going to add to it the index I and the index J. This is, by the way, just like how they're doing it in this example right here. Okay, so hopefully that made sense. But now we have to do a couple more things. By the way, if I has been used like here, if we ever got inside here, is there any reason for us to continue on with this J for loop? There isn't, because once I have been used, there's no reason to use it again, right? So all we gotta do after that is just break out of this loop. And here's another thing. If we were looping through it, but that J value that we're looking at right now has already been used, we don't want to use it again. So we gotta do a check in the beginning. We gotta say if use dict at j is true, like that, or because that's a Boolean, we could just use that as the if condition. If use dict at j is true, then we just want to pass that by writing continue, like so. But not only that, our I dictionary, our I could also have been used because maybe we loop through, this is I, this is j, we loop through all the j's, and then we ended up using one of these guys. So we got to make sure in the beginning that our I value has not been used either. If use dictionary at I, then continue, like so. Hopefully that made sense. Now let's read our directions of our rules again and make sure we didn't break any of them. We can't use indices more than once. And yes, we are following with that because we're always checking before we do anything. If it has been used, then just continue. So we are not using any of our indices more than once. What about this? If an index can add with more than one, use the smaller pair of i's, of indices. And yes, we are following that because of the order that we're going. We're starting with the lowest pairs, lowest possible pairs first, and then comparing like that. So whenever we add, I can guarantee that we are using the smallest pair. So for example, let's say we had 2 6s like before, like this, right? We used this 1 and 6, we added it, we set them true, and then we broke out of the loop, so we will never use this 1 and 6 again. And let's say there was another 1 here. Then he will never be paired up with this 6 because he's gonna be paired up with this 6. So it works. It will always work. Let me just send my example back to the original. Now let's just make sure that this gives us the correct output. So what are we gonna return? We're gonna return our output like so. Let me run the code, put a console log upon this function call just to make sure that we get, what is the correct answer for this one? I think it's 11. And I do get 11. Now let's make sure that this passes all the Freecodecamp tests. Bring this over here. Sorry about my voice. I think I have a little bit of cold right now. Run the test and we pass. Okay, so now let's think about a couple ways we can optimize this. So do you remember why we made this use dictionary? It's because we want to keep track of which one has been used or not, right? But we don't even have to build this up like so. We could just make this as an empty dictionary. Because if it's an empty dictionary and we try seeing whether the value of it is false or true, if the index I doesn't exist in this use dictionary, this will give us back undefined, which is a falsy value. And if we do end up using it, we're just making new objects inside here that will say that key, that index will become true. So this will also work. And let me just show you guys by running the code again, and we still get 11. So this looks not only much cleaner, but we don't have to use a reduce method, making this a little bit more performant. Now let's see what else we can do. I'm sure there's other ways to solve this question. But right now we're dealing with O to the n squared, although not really. I think it's n log n, to be honest, because this j, we're not looping through every single element either. So I think it's O n log n. Please correct me if I'm wrong in the description, in the comment section below. But I think this is good for now. Let's just get this code now. Bring it over here and run the test, and we still pass. All right, guys, so this was Pairwise algorithm. Hope you guys enjoyed this. Guys, please, if you like my content, please click like. That helps me a lot. And subscribe below to get more content like this. Anyways, guys, happy coding, and I will see you guys next time.